Fancy dancy. All right, Unit C is going to be systems of equations. So if you want an overall unit name, we're looking at systems of equations. Today we're doing C-1. Struggling here with this camera setup. One moment. Still struggling. Alright, I'm going to just move this for a second so I can write C1. So C1 is graphing systems. This unit is really, really short. It's going to feel a little bit longer because we do have MEA happening in the middle of it. So because today is a short week, it's going to feel like it lasts a little bit longer because it's going to last about 2 weeks. But really, it's only about 7 days long. Okay? It's a really, really quick unit. And overall, it's a unit that it's going to be talking about a couple new ideas. But it's also a review of other old ideas. It's taking what we've learned and applying it to a new situation. Okay? So first off, a system of equations. We have two definitions that are a little bit lengthy here. All right, all of our goals in this chapter is to talk about a system of equations and to find a solution to the system. Okay. You can do it. All right, systems of equations means that we are working with two or more equations at the same time. So we're working with two or more equations at the same time. So a system is like a process that's in place. So when we talk about systems, we're talking about having those multiple equations that are in place. Smokey, go to class. Go to class. Alright, then we have a solution to a system. Now this year when you work with systems, you should have been exposed to this as an 8th grader or when you took Algebra 1.1 or Algebra 1 as we call it now. If you weren't, this is usually like this is the final chapter that should be kind of review. Okay. A lot of times this is, when I taught 8th grade, this was like the chopping block when it was like, MCAs are coming up and we have like one thing we can learn, and this was like, we're not going to do this one. Okay, so if you did not learn this, that's okay. But because this is still kind of an introductory year to systems, we're only going to be working with two equations at a time. I know it says a system of equations is two or more. When you get to Algebra 2, which should be in 2 years, next year you would take geometry, then the year after you would take Algebra 2. When you get when you get to Algebra 2, you're going to be dealing with systems that have 3 or 4 equations at the same time. Okay? Today, or this year, when you do solution to a system, we're only going to be doing it with 2 variables. Can anyone guess what 2 variables we'll be working with? I'll give you a hint. The first one is x. Oh, y. So a solution to a system is always going to look like xy. In our case. In the future, you might be working with something that has lots of missing variables, like an x, a y, a z, an m, lots of things. But this year, we're just doing x's and y's. Okay, so it's values for the variable. Good morning. We got new seats. You're sitting by the window up there. Okay, values for the variables that make all equations. True. Okay, so those are our two longer definitions. Those are going to be really important because that's kind of what we're focusing on this whole chapter, are these two ideas. We're going to be finding solutions to systems, which means that we're going to be finding an ordered pair that works for all the equations.
Miss, how is my cologne here?
I don't know. I didn't grab it. If it's there, then yeah. Hi, Humpty. There is no seating. You sit right in front of Lucy.
No, I don't know where's that.
Okay. Alright, so really important vocab there. So if you need to take a quick picture of that because you didn't get it quite written down, that might be good. Alright, so we're going to start by talking about a system and solutions. Oh, thanks, Hamdi. Usually that was moved. My last class was doing group work. So it was just a little nuts last period. Alright, here we go with our first example. So our first example is going to ask, is it a solution? So for questions that say, is it a solution, what kind of answer should we have? Either, yes, it's a solution, or no, it's not a solution. So those are going to be our answers for this one. Is either we're going to have yes or no answers. Okay. So our system is going to be y equals 2x minus 3. And 4x plus y equals 3. Okay, again, this year we're only going to be working with 2 equations at a time. So because we're working with these 2 equations, we don't need to have a bracket. Once we get like 4 or 5 equations, we'll put in a fancy bracket. But it'll look like this. We're just going to put it there just so it's in your brain. But generally this year, just because it's only 2 equations, you won't see that. And that bracket's just there to show that these are grouped together. We're working with them at the same exact time. So I want a solution. I want an ordered pair that when I plug it in for this one, it makes a true equation. And when I plug it in for this one, it makes a true equation. Okay, that's our goal, is that it works for both. So our first ordered pair we're going to do is 2, 1. Okay, I'm going to kind of split my work area into 2 parts. On this half, I'm going to show one of the equations, and this half I'll show the other. So which equation, not which equation, we're just going to split it up into the first and second. So we'll do y equals 2x minus 3. And on the other side, we'll work with that other equation, 4x plus y equals 3. What do we call that 2, 1 when we have that parenthesis, number, comma, number? Ordered pair, good. And an ordered pair is called an ordered pair because there's a special order to it. Okay, that first number is always what? X. And then the second number is always y. That's why we call it an ordered pair. If you're like, why do we call it that? It's because it's in a special order. We should know x comes first and then comes y. So I'm going to replace these values out. I'm going to switch them out. So instead of y, what number is going to go in for y? 1 equals, and then I have 2. Now instead of x here, what's the x from my ordered pair I want to check with? 2 is that x minus 3. And now I'm going to see if that's a true or false equation. Okay, so over here we're just doing our order of operations. That's A1. So are we going to multiply first or subtract? Good, we multiply first. 2 times 2 is 4. 4 minus 3 is 1. So we get 1 on one side equals 1. Is that true or false? True. Did it work? Yep. So I'm going to put a little check mark. Yep, it worked with a yes. Okay, so now because it worked for 1, I do have to check it with the next one and see, does it work for that other equation? So I'm going to replace our x and our y with those numbers that we said x and y should be. So I have 4 times, what's my x? 2, plus my y. What is our y? 1 equals 3. Okay, I didn't put that 1 in parentheses because it's just that y, so we don't need that parenthesis. Yeah, I would love that because I was going to mark you tardy. Look at you go. Crushing it. Alright, so now we're going to multiply. 4 times 2 is 8. 8 plus 1 is 9. Does 9 equal 3? No. So that did not work. Our answer is no. So my question is it a solution to the system? Did it make all of the equations true? No. So if it did not make all of the equations true, is it a solution? No. So my full overall answer is no. And that's because I had a yes, but I also had a no. In order for it to work, both would have to be yeses. You can take out your notes up, daisies. I got it stopped. You should be good. Alright, let's try one more. We're going to try the ordered pair 1, negative 1. So again, I'm going to split up my workspace so it's kind of into 2 separate spaces. My one equation is y equals 2x minus 3. And then my other side I have 4x plus y equals 3. If you want to try and work ahead on this one, you can go for it. It's very similar to our last one. Alright, what our goal is that we're going to plug in those values for our variables. So which one is my y? We got negative 1 because the y comes second. What comes first? X. Yep, the 1. So y is negative 1 equals 2. And then it's times x. I could do times with a dot. But usually when we do systems, for some reason at this point, we like to use parentheses. So we're going to put in that 1 minus 3. And we're going to just double check what that 2 times 1 minus 3 is equal to. Good. 2 times 1 is 2. And then we still have to do 2 minus 3. Why is it negative 1? Good. We're starting with a smaller number, and we're taking away a bigger number, so we would have to pass by that 0, go to the negatives. So is this a true or false equation? True. So yes, it works here. If you want to put true, you could. I like to just put yes or no, because that question, is it a solution, is a yes or no question. Correct. Alright, so now 4x plus y equals 3. So we're going to do 4. And then instead of x, it's times x. So we're going to say times what? 1. Plus negative 1 equals 3. Yep. can give people a second to write that down though. A lot of people worked ahead, I think. Either people worked ahead or they're a little behind. Alright, so 4 times 1, 4. Now if I start at 4 and I go 1 in the negative direction, where would I end up at? 3. Is it positive 3 or negative 3? How come it's going to be a positive 3? Yeah, we had more positives to start. The 4 was bigger. Is negative 1 enough to go past 0? No, it's just going back one step. So does it work for that one? Yep. So if it works for both, is 1, negative 1 a solution? Yes. Okay, let's think back just for a second. Back to that first part. This one where it said no. If we started with this one and I knew that this was a no, do I even have to try the second one? No. As soon as I know I have a no, as soon as we find out one of the answers is a no, the overall answer is no. Because in order to be a yes, they both have to be yes. Okay? So a yes, no is a no. A no, yes would be a no. A no, no is a no. Yeah? Yep. It has to be a yes and a yes. Alright, I'm going to go to the next page because we're going to kind of start a new topic. So if you have like 3 lines, you can go to the next page. If you have a lot of lines left, some people are really good about conserving lines. I get so self-conscious when I look at your page, Holly. You just always have everything so crunched together, and I'm like, dang, I use a lot of space. Alright, I'm going to grab 2 colored pencils. While you're in your bin, you can grab some colored pencils, glue, and scissors if you want, or you can just go in there in a second. I'm going to grab orange and green today. So if you'd like to use orange and green, you can. Alright. We have 2 more examples. I know this feels like a lot because it's kind of new, but it's taking a lot of what we've already learned and applying it in a new situation. We already learned about true-false equations. Now we're just doing it with multiple equations. Alright, we already talked about graphing. When we graph systems, that line is a line of ordered pairs. Okay, when we graph a line. So if I start by graphing a line, let's do my green one. Okay, now if I want to draw another line, there's kind of 3 options we have. Our first option is one that a lot of people think about. If I draw a line, it's going to cross that line. So if I draw 2 lines, because I have a system, and they cross, how many places do those 2 lines cross?
1.
In 1 space. So how many ordered pairs do both those lines share?
1.
Just that one. So that one spot where they cross is going to be our one solution. Okay, so that's one option, is that the lines cross once. What's another option when I draw 2 lines? That they don't cross, right? Somebody I think said it. What do we call those lines when they don't cross each other? Parallel. Yeah, that's why we call it parallel parking. When you're parallelly parking, When you're doing parallel parking, you're trying not to hit the curb. So you're parallel with the curb. So they never touch. So are there any ordered pairs when they're parallel? Are there any ordered pairs that will be both on the orange and on the green? No. So this we're going to say is no real solutions. Now you might think that's weird that we put in that word real, but that's because sometimes there's things called imaginary numbers, which we are not learning about this year. Thank goodness. Okay, in the math world and in the real world technically, there are things called imaginary numbers, which is very confusing because we're like, imaginary, that means they're not real. But really they are real because they exist, but it's very confusing. So we call it no real solutions because it turns into this whole thing, and we're just not going to deal with it this year. So rather than dealing with imaginary numbers, we're just going to go with No real solutions. All right, now there is one other situation here that can happen. Okay, is if I have a line, and rather than just sharing 1 point or sharing no points, they're going to share all the points. Those lines are actually right on top of each other. So if it turns out to be the exact same line and they have all of those points together, how many of those points is that? Every. On and on and on and on, forever and never and never. And what do we call that when something goes on and on and on, forever and never and never? Infinite. So this is infinite solutions. Because remember that line is going to go in both directions. On and on and on. Alright, you guys are going to get sheets of paper at your desk that I did not cut apart yet. On the papers, there are going to be 6 graphs. You need 2 of those graphs cut out. And then you are going to glue them in, just one on top of the other, one here and one below it. And then we're going to show our work over here. So as I pass out paper, you only need 2 graphs. Everyone needs 2 graphs. So you might need to work together to cut those apart. So you guys will only need 1 sheet because you all need 2. I'm going to share paper. Taylor, when you're done, will you pass yours over to Faith? Do you appreciate And then Adrian can be share with the so you can pick you out and pass your sheet over there. So you need 2 graphs. So even though I only handed out like 1 sheet of paper, 2 sheets of paper per table, you're just cutting out 2 graphs for yourself. So pass those around. Trim them up a little bit so they look a little nice, but they don't have to be perfect. We don't need to spend 5 minutes cutting them out. They're just graphs. It's not like you're gluing in a photo of your grandma and you need to make it look really, really nice. It's just a graph. Right? No one laughed at that. That was a really funny joke, you guys. Thanks for your honesty. I thought it was funny. Alright, so then when you glue them in, you're just gluing them in one on top of the other. And then leave some space for some work. So if you're gluing them in side by side rather than vertically, you're gluing them horizontally, that's okay. Just make sure you have some space for some work as we're going to show our work. Okay, you're going to still want those colored pencils out. And then if you have a ruler, you'll want that ruler out or a straight edge because we will be drawing some lines. Awesome. I'm going to forget that's there tomorrow. I'm going to be like, what the heck? Alright, so remember they don't have to be perfect. We're not gluing in a picture of your grandma. 2 graphs. Don't tell her you're going to use the other 2 graphs, okay? And then your chef you can go. Okay. Or actually pay them. Even if you're not taking okay, but that's because you don't try. Because what? Give you about 40 more seconds to try and get those fluids in. Clean up everyone else's, but then there was paper on mine. I'm not tall enough to get it. I threw the stick in there by accident. But I can't reach it. You know, reach it from you, Daisy, so you're taller than me. Can you reach above this and get it? Too short. Appreciate. Alright, here we go. So, for our first one, we are going to do this as technically example 2, because we did example on the front. If you want to relabel it example 1, that's fine too. Alright, we're going to be graphing 2 equations. So we're going to graph 2 lines on the same graph to see if they have any ordered pairs in common, and if they do, how many. If they have ordered pairs in common, we are going to name that ordered pair. Alright, so for this first one, we have y equals 1/3 x plus 4. I wrote 5, but I wanted 4. Yikes. Sorry. And then our second equation is 5x plus 3y equals -6. Alright, so I'm going to color code these. I'm going to do the orange one on top. And the bottom one is going to be my green one. Okay, now based on last unit, in unit B, which line is going to be the easiest one to graph right now? The top one or the bottom one? Why is the top one going to be really easy to graph? It's written out for us in what form? Good. Y equals mx plus b. We call that slope intercept. Good. So what is my slope for that one? 1/3. That tells me my rise is 3. And then what is my b? What is my y-intercept? 4. Alright, so when I graph this, do I start with my rise and run, or do I start on my y-axis? Good. My y-axis is this one that goes up and down. If you want to label it y, you can. This is our x. That might be helpful. Alright, so I'm going to start at 4 on my y. 1, 2, 3, 4. It's positive 4, so I went up 4. And then I'm going to do my rise and my run of 1/3. So from that orange point, I'm going to go up 1 over 3. Then from that point, we'll do that again, up 1 over 3. Alright, if you draw really straight lines or use a straight edge, you don't have to go in the other direction. If you're not very good at drawing straight lines, or you don't have a straight edge to use, you're going to want to go in the other direction as well. So from that 4, instead of going up 1, we're going to go down 1, and then we'll go left 3. Down 1, left 3. Okay, and then you can use that straight edge. If you use your ID card, you can use the side of a notebook, somebody else's notebook, a folder, the side of your phone, if your phone case isn't bumpy. Alright, let's talk about that green equation. What form is this in, that green equation? Does anyone remember that form? Good. AX plus BY equals C. Does anyone remember what we call that? Standard form. Do we know how to go straight from standard form to the graph? No. It sucks. Just kidding. We love standard form this chapter. This is the only lesson that we really don't like it too much. Okay? So what we need to do is we need to put it in that y equals mx plus b form. So we're going to solve that equation. Our goal is to get that y by itself. So if I want to get y by itself, should we undo the 3 first or the 5x?
5x.
Good. How would we undo when adding 5x? Minus 5x. If we do it to one side, do it to the other. All right, bring down that 3y. Now, for y equals mx plus b, do I want to write negative 6 minus 5x or negative 5x minus 6? Yeah, it's okay if you do it the other way. You just are going to have to you'll just need to switch them around at the end. So you'll just have an extra step, and that's okay. Alright, my goal is to get y completely by itself. So now I have to get rid of that 3. So how would I undo a multiplying by 3? Divide. And if I divide one thing, I have to divide all the things. So we end up with y equals, can I do negative 5 divided by 3? No. Can I simplify that fraction? Nope, it just stays negative 5/3 x. And then can I do 6 divided by 3? Yeah, what's that? Negative 2. So I can write it as either a minus 2 or you could write it as a plus negative 2. Alright, now we're ready to graph that. That's my green line. It's the same graph as this one. I just wrote it differently. So that way it's ready to graph. So what is my m? Negative 5/3. And my b? Negative 2. If you want to write it out separately, you can. I'm going to just leave it like that for now. I'm going to start at my b on my y-axis. So I'm going to start at negative 2. I'm going to do my rise and my run. So I want to go down 5 over 3. Now, here's the thing about being off the graph 1 is that this arrow is pretty much one line off. So if you can kind of follow that arrow, then that's okay. If we're more than one off the graph, we don't like it. But in this case, we can find another point. Instead of going down 5, up 5. But where does that negative come in? Hi.
Did you find a black jacket up the last class?
No.
Nothing?
Yeah, I got nothing. Sorry. I'm pretty sure she didn't have it in this class.
She did. Did in and not out, so it's a vanishing jacket.
Really? Anyone see a black jacket?
No.
I don't think so.
Yeah, because this is mine.
No.
Is that one?
Is that yours? Give it in a second. 1, 2, 3.
There was black jacket right there?
Nope. Still not there, so that. Nice, Mikey one. Even when I looked, she doesn't look very hard, I don't think. Sorry.
Oh, you're good. Thank you. Sorry for the interruption.
You're good. Alright, so we're going to draw that line. Alright, and our goal is to find out how many solutions, and if there is a solution, what is that solution? So in this case, do those lines share any of the ordered pairs? Yes. How many ordered pairs do they share? 1. So how many solutions? 1. And I want to write that solution down as an XY ordered pair. So what is my X of that point? Negative 3, because it was left 3. And then my y is positive 3 or negative 3? Positive, because it's on that positive side. It was up from that origin, so positive 3. You got it. And that's our answer. That's that solution. Okay, so if I were to take Desmos, and this part's not required, it's just to show you what we were doing before and how that applies. If I take negative 3, 3, and I put it in for my x and my y here, so I'd have 1/3 times my x, negative 3, plus 4. Do I get 3? Yep. If I put it in for this one, 5 times my x, negative 3, plus 3 times my y, 3. Do I get negative 6? Yep, so it works for both. And make those true equations. All right, we have one more example. I know these are really long notes today. All right, we got number 3. Number 3, we have two equations. We have negative 10x minus 8y equals 24. And then our second equation is y equals negative 5/4 x minus 3. So when I graph, I like to color code. That way I know which one is which. I'm going to do the top one orange again and the bottom one green. You're right. One is ready to graph right away. We don't have to do a whole lot of work to get that one of them graphed. Is it going to be the orange one, the top, or the green one, the bottom? Yeah, the bottom. Because it's in that form, y equals mx plus b. What is my m? Negative 5/4. 5/4, yep. And what is our b? Negative 3. So we have our x-axis and our y-axis. If you'd like to label those, make sure you label them. Might help. Alright, I'm going to start, it's my green one, so I'm going to do my green color pencil. I'm going to start by going down 3 and making a point. Now, those of you that maybe got distracted when Mr. Scholar came in to look for that jacket, we're going to kind of talk about it again here. Can I go down 5 this time? No. And when I go off the graph, I'm more than one off. So I don't want to guess that, because that's going to screw things up. So instead of going down 5, I'm going to go up 5. 1, 2, 3, 4, 5. But then that negative still has to come into play. So because it's a negative 4 now, am I going to go left or right? Left. Yep, and that's the only 2 points we can do, so we just connect those two. Alright, now that orange one we want to graph on the same graph, so we need to change that one up. So I'm going to do a little arrow here. I'm going to copy it down. Negative 10x minus 8y equals 24. And we want to be able to graph that. So in order to graph it, what do we want to solve for? Y. That's our goal, is to get y by itself. So to get y by itself, are we going to undo the negative 8 first or the negative 10x? Good, the negative 10x. And how would we undo a negative 10x? Good, plus 10x. We do it on one side, other. Okay, we bring down that negative 8 equals 10x plus 24. Just switching those around. What's really important on this problem is that that's a negative 8. Okay, that minus transformed into a beautiful butterfly. Okay. Alright, not quite done yet. What do I need to do? Divide everything by -8. Yep. Alright, 10 divided by -8. Can we divide 10 by -8? No. But can I simplify that? Yeah, I had both 10 and 8 by. Somebody said it. 2, 5, 8 divided by 2, 4, and then that negative just comes out front. X goes off to that side, plus, what's 24 divided by -8? -3. Alright, so now that's ready to graph. Oh, that is my orange. Alright, so where are we going to start on our graph? -3. Oh, we already have a point there. Awesome. My slope is -5/4. So am I going to go up 5 or down 5? We'd like to go down 5. Can we? Nope. So we're going to go up 5. And then we'd go to the left 4. What? It's the same line, which we could have figured that out because when we solved it, it's the exact same. This one just says plus -3. This one says -3. But really, they're the same, right? So, are there any solutions to this? Yeah, they share ordered pairs. How many ordered pairs do they share? All of them. And it keeps going on forever and ever and always, so it's going to be infinite solutions. Okay, I know that was a really long lesson, and I love, love, love how much you guys all paid attention to that. The majority of you, I had like a solid, at all times I had like 88% of you, which was great. I know. There is a quick